start working on this. So basically, yesterday we built a single word cloud with one single company data. So today we will be building a comparison cloud. The comparison cloud means the cloud, it will be same word cloud, but it will have three parts. Keywords, what are the keywords within Google Tweets? What are the keywords within Microsoft Tweets? And what are the keywords within the Facebook Tweets? Since we want to do a faster analysis, instead of downloading the 18,000 tweets, I have just downloaded 1,000 tweets of Microsoft, @Microsoft, @Google, and @Facebook. The user handles of this particular company. And I've saved you and I've already sent it to you. So what you can do is, all of you can import them into R. Whoever, I think most of you don't have. So FB is equal to read.csv file.choose. This is an import command. Click on it. It will open a browser window and then choose the CSV file of the Facebook. Then Google is equal to read.csv file.choose. Again, I am downloading the Google Tweets, importing the Google Tweets into the data. So read.csv file.choose will open a browser window, either it open in the front or in the back end, or if you check your taskbar in the down, you will see it. And third one is what? MSFT, Microsoft, is equal to read.csv file.choose, null brace, control enter, and then choose the Microsoft Tweet. So I have scraped data for all the three companies tweets, and then we have shared you with in your email the file. You can it. Let's see how many tweets we got actually. So for Facebook we got 1,000 tweets. All three companies we got 1,000 tweets. See here, you can see here. FB 1,000 observations of 90 variables. Google 1,000 observations of 90 variables. MSFT 1,000 observations of 90 variables. So we all got all the three companies. We got the latest 1,000 tweets. So 1,000 tweets we are using because so that you can go up to 5,000. I have built a comparison cloud with 5,000. But sometimes what happens is some companies might not have 5,000 tweets. That time you have a sample problem. So let us keep it as equal sampling. All three, that way it is safer. I think 2,000 tweets also you can easily get because these are highly active companies. You can easily get them on Twitter. @user handle. And user handle. If you download this, we can save them into CSV file, and then we will build a comparison cloud. So I have imported the data which I have emailed you. So Facebook 1,000 tweets, Google 1,000 tweets, and you can do it anything. You can also import PDF files. Like I can give you an idea nowadays. People are what is the central bank monetary policy documents. Central bank monetary policy.
Sir, voice is not clear, sir. It's breaking.
It's still not clear?
Now I'm getting disturbance. Yes.
It is clear now, right?
Yeah, now it's clear. Yes.
Okay. You can use monetary policy documents of different central banks and compare them. There is one thing one person has did it as part of research last year. So RBI monetary policy, he downloaded all the 4 documents in the year, and he downloaded Fed policy, and then he compared them using a word cloud. So PDF tools is the package. If you want to import PDF file, the package is PDF tools. There is a R package called PDF tools. You have to install this PDF tools package and also install Tidy Universe. Now, Tidy Universe is a combination of packages. It has packages like Tidy, DPLYR, Rearrange. So it's a group of packages which are being designed to work with large-scale data. Yesterday we got a warning in sentiment. So instead of using a data frame, use it as a table. So Tibble is the latest thing which is easily used for deep learning. Tibble is also data frame, but it has a different structure. So you can use the Tibble structure also. Tidytext is a package. You can also use a package called Tidytext. So there's a package called Tidytext which works with Tibbles. It's a new package which was launched in 2019 or 18. Full beta. So Tidytext is also a very interesting package. So basically, if you can import PDF files, convert them into text, and then you can straightforwardly start working on cleaning up this content, and then do the document term matrix, then do everything, term document matrix according what we have done yesterday. So PDF files also can be done. Like I know one guy who is doing a PhD on text mining of annual reports of the company. So you have annual reports of the company. So you can do text mining of annual reports of the company. So what he is doing is he is taken top 50 Indian companies, their annual reports for last 3 years, and he is trying to import them into R and then into Python, and then he is trying to build a model. What they are reporting, what they are trying to do analysis. So when you're doing it, large scale files, Python is more preferable than R. R also equally works, but Python has such comfort level, so people are using Python for large scale data. But R also is capable of doing it. You can use both R or Python. These are some of ideas you can do. You can compare companies, Nestle, FMCG companies, customer care. You know, customer care is also handled on Twitter. You can compare those companies' customer care handles, how they are responding using this topic modeling, sentiment analysis, and all those things. So all these things can be done in text mining, which are being done across the world as PhDs also. Today morning, only one person called me regarding impact of news on stock prices. So he's trying to work on impact of news on sentiment of stock prices. So you can do all these are related to text mining only. Okay, because text mining is now one of the leading PhD what you call topic for a lot of research scholars. So all of you have imported the data, right? Can I move forward? All right. Now what we do is after we individually clean the text, right? So one thing so we could do. Now we'll create a function. We'll create a function called clean underscore text. Clean underscore text. We'll create a function called clean underscore text, which will clean all the tweets with a single command. All the things which you have done, which you have written yesterday, will be considered here. So let us say function. We'll create a function called clean underscore text, function of tweet text, because we already named it as tweet text. Function of tweet text, and then curly braces, curly brackets. Function of tweet text, curly brackets. Now press enter. So the curly bracket will go on, and then you get a cursor here for indentation. So the cursor automatically moves here. Okay, now go back to yesterday's file, and in yesterday's file we have the cleaning commands, right? The gsub commands. See from here, gsub commands, right? All the gsub commands except the head. We'll remove the head command later. All the gsub commands till to lower. So all the gsub commands till lower. Copy them. Control C, and then we'll paste them here. Control V. And we have to remove the head text because otherwise it will create a problem. So what I did was I am creating a function called clean underscore text. So function of tweet text. You can use function of X, but again we have to change all the tweet text into X. So instead of that, I said function of tweet text. So remember, all these things should be in a straight line. So this clean text, once you create, it will be there in your thing. Every time you don't need to run. You can simply say clean text. That way your content will be clean. So this is a function we can use it forever in your R. So it's very simple to create the functions also in R. Not that complicated in C or Java. It's a very simple syntax. So So all we have to do is I'm just removing the head because we don't want the head every time. So we just need the actual content. Okay. So, and then we have to add one more command called return in bracket tweet text. So what this clean text function will do is it will clean up the text with single word. Yesterday we have done it multiple times using multiple words. This will do it off in one. Once you create it, it will be there in your app. You can always refer to it as clean text.
So this clean text will limit it to this particular project only, or we can.
It will be there in your R environment. Not only this particular project, you can use it in other projects also.
Right. Thank you.
So just like it will create a function. See, like we have mean function, right, which you can use anywhere. So it will create a function in like in base package, one function called clean text. I'll show you. So let me run this. So anything missing? No. All in straight line. Select the command, click on run. So it ran. The command run, we didn't get any error. Now if I type here clean text, see, global environment. So it is in all in the R global environment. It created a new function called clean underscore text. So this function will clean up the text every time. We can just use it as a function now. So all of you just copy and paste them. Make sure the indentation is there. So the standard syntax for creating a function in R is first define the function name, function of, you can give the name of the function and then the curly brackets. The arguments have to be indexed into curly brackets, and in the end you have to give a return command or a print command. Either you give a return or print must be there, and then you close the curly brackets. So the standard indentation is must here. The indentation is straight line. See here, all of them must be in straight line. Otherwise you'll get indentation error. So this is the easiest way of doing the cleaning.
I have a question, sir. Yesterday I was practicing the things. By running all these commands, the backslash has not been removed from the text. So backslash was still there.
So what happens is, if backslash is still there, you need to find the relevant code for backslash in the internet. So what happens is sometimes they get sticky, which means they got attached to a certain word or a letter. So what you can do is you can search in Google Stack Overflow how to remove the backslash. But in the final code, it will not come.
So it was there, sir. I would try to figure it out, but I'm not able to crack it down. I use a complete.
There will be, see, like this, there will be a backslash also certain symbol. So if you look at this symbol, this will remove the spaces at the beginning of the tweet. This will remove the spaces at the end of the tweet. So we create spaces, right? All these commands will create spaces at the end. So either at the end of the tweet, if the space is there, it will be deleted. If there is a space which is there at the beginning of the tweet, it will also be deleted. So I'll tell you, by the end of the session, I'll tell you what is the code for backslash. You will have a codes for all the things, the C, Java. We call them as regular expressions. You are engineering guy or non-engineering?
Engineering guy, sir.
You might know regular expressions, right?
Yes, sir. Yes, sir.
Only, which I'm using here. These are all regular expressions only. So
Yeah.
you have to find the regex for backslash.
Yeah.
And you just need to gsub it. It will automatically go off.
Right.
Yeah. So search for the. I'll also give you the complete list of regex I should have in my Windows laptop. I'll send it to you. All right. All of you have done it. The clean text. Now, FB clean is equal to clean underscore text FB. So we have named it as FB, right? So I have named it as FB. So control enter. So the text would be clean, FB clean. Similarly, GOG clean, Google clean is equal to clean underscore text GOG. Will clean it up, clean all the code. Similarly, MSFT clean is equal to clean underscore text MSFT. See, it just cleans very fast because it's only 1000 tweets. No? It cleans very, very fast. Now, if you see head MSFT clean, comma 3. Let's see top 3 only. Oh, what did it do? Oh, funny thing. It is not giving you the same thing happened with all, huh? There is an error somewhere. 1 second. Let us check the function once. To lower is also there. Okay. Okay. Let us say or let us see what is the exact content we got. Let FP. Oh, sorry. We forgot the important stuff. You have to select the text, na? Okay, we can keep these things. We didn't select the text. So before we run clean text, we need to select the text, right? Because 90 columns are there, na? So FB text is equal to FB dollar text. Control enter. Similarly, Google text is equal to GOG dollar text because it is running on all the columns. So that's why we are getting that cancelled out thing. And then MSFT text is equal to MSFT dollar text because we want only the text part of it. So we don't want all this part. Hello. మేడం మీరు కింద ఉంటే చూడండి డే 2 లింక్ అని ఉంటుంది మీరు పైన డే 1 లింక్ క్లిక్ చేసుకున్నట్టున్నారు కింద డే 2 లింక్ ఉంటుంది అదే ఈమెయిల్లో డే 2 లింక్ సెపరేట్ రెడ్ కలర్ లో సెపరేట్ చేస్తుంటే చూడండి Now we have selected the text and now we have to give the text as clean text. Every text, Google text and MSFT text. Now let us run the text command. Now head MSFT, comma 3. Oh, sorry, MSFT clean, comma 3. See, now you got the text. You got the top 3 text. See, all cleaned up. All cleaned up text we got. So basically, we have to first select the text and then pass the text to the clean text command.
Sir, so can we go to results, sir?
Yes, sir.
Can we go to results? Again, sir, head 3 text, whatever you just got.
Yes, 1 second.
Yes, sir. So now within year /n/ni.
This one, right?
Yeah.
Yeah, let us check what is that. Actually, you have to search in internet what that means. Yes, match line breaks. That is line breaks. Slash and are R and N are there. No? They are called line breaks. See, in Stack Overflow, you'll see line breaks. So we have to remove the line breaks also. So you can try this one. GSub Control C. So before lower, you have to add it. So tweet text is equal to GSub open bracket GSub open bracket single quote paste the thing comma single quote comma tweet text. So this will remove line break. Okay. So what we can do is now, if you don't want to see it, first run the clean text function. Control enter. Okay. Okay. Now we'll select the text again. Then we'll pass them to clean again, and then now you can see they are gone. Got it, Sahil?
Yes, sir.
Got it? So
Yes, sir.
it's easy to see, sometimes we can't fix it. There are a lot of regexes, around 200 are there. And emojis and all these things keep on coming, right? So a lot of things happen. So just search it in Stack Overflow, you will get it. Once you get it, you can add it to your GSub and then you can clean it. So when particularly WhatsApp is a problem, emojis will come. Now, a lot of people use emojis in WhatsApp. So that is one of the problem in WhatsApp, where you have to find different regexes for different types of emojis, and then you have to clean the text. So otherwise, this is the clean text function, and then we have cleaned the text. It's all regular expression. So just remember that regex.
Excuse me, sir. Can you please paste the code in chat box?
This whole code, huh?
Yes, sir.
Clean text function, huh?
Yes, yes, sir.
Yes, 1 second. Yeah, I'll do that. I pasted it in the chat window. So once you create this function, it will be there forever. So you did not worry. You can just simply blindly pass the function clean underscore text, or you safeguard this into some text file, some place you can save them in your system. If at all, sometimes our updating will create problems. That time you can work with easily use them and clean the text.
Sir, even though we are working with the same data, the results would differ, right? The output.
Output will differ, ma'am. This is MSFT output. If you want to see Google output, simply replace these are 3 different data frames, ma'am.
Nee, I need MSFT only, but I got a different output, so I was checking.
No problem. Because what happens is there is a time lag between your download and my download. Your speeds might have come into place, na?
Okay.
Actually, also Sahil, by the time he got the rating, he got 17,791. But whereas I got only 17,774. Because streamingly, it will keep on, it's a live stream, na? New tweets will be added. So don't worry about that. You got 1,000 tweets, you got the most latest 1,000 tweets.
Okay, sir. Okay.
So only some 5-10 tweets might have been done in the within this half an hour span or something.
Okay. Yeah.
All right, shall we go ahead?
Hello. Sir, till now we have imported three different tweets. One from FB, one from Google, and one from MFT.
Ah,
And now we have cleaned it.
yeah, there are three different frames.
Yeah.
Now we will combine them. We will start combining them into one single vector for further processing. Okay. So for that we'll start the addition of process. Now FB is equal to paste open bracket FB clean comma collapse is equal to double quotes with space. Similarly, book is equal to paste, or let us say we'll name them as full names, Facebook, so that you can have the names finally when you look at it. Google, paste, book, clean, comma, collapse is equal to double quotes with space. Similarly, Microsoft is equal to paste, MSFT, clean, comma, collapse is equal to. So I'm just running these three commands. Now all is equal to T of vector of Facebook, comma, Google, comma, Microsoft. So now we will check the document. Now if you go to here, right hand top corner, you will see all is a character of 1, 2, 3 columns. So it has created 3 columns with the tweet. So what exactly it has done is, I'll show you. It has created a 3-column data where the tweet will be in only single column. So it didn't break it into different columns. There is no data frame thing. Okay, it's still not in data frame process. So characters, yeah. So we can't use. So we have to convert it into data frame and then see. To do that, all df is equal to data dot frame in bracket all. Now you have all df, right? Now you can see the what actually I'm talking about. So only 3 tweets it took. Okay. Initial all is out. All right. let us see. Actually, data frame I have missed somewhere something. Otherwise, it should show it in a data frame, single data frame. Okay, let us don't do this all ds command. Keep it as all. Okay. Now we have to remove the stop words, right? So all is equal to remove words. Oh, we have to activate the TM package. Sorry. So library TM, text mining package. So library TM. So once you paste them into a single vector, now we'll start the library TM. So all is equal to remove words. So we'll remove the words in all, comma, stop words. In bracket we give English. So we'll say stop words English. English stop words we want it to remove, comma. Then what else we want to remove? We will also remove no, we will keep the names as it is. Okay, so close the bracket here, control enter. So what it will do is it will remove the stop words, is and the, that, all those stop words should be removed. Okay, next we will create the corpus. Corpus is equal to corpus vector source all. So we have created the corpus of all the words. So we are now going back to the same process what we have done yesterday. What we have done yesterday in terms of.
So if now I run head command with corpus, it will show top 3 tweets from which file?
Sir, head cannot be run on this data now, sir. Kyunki this is not a data frame, na? Our data is in vector. It's not in data frame.
Right, right.
So
Okay.
the data is in a vector format. So when you have your data in vector format, you cannot run the head command. Head command can be run only if the data is in
Data frame.
data frame format. But we'll see. We'll get the final output. Now then we can see. So all TDM is equal to term document matrix corpus. So we are creating the term document matrix. So the process is all TDM term document matrix. Okay. So we have created the term document matrix, which we have created yesterday also. Now all TDM max is equal to as dot matrix all TDM. So we have to convert it into a matrix format. So now the data is not in a vector matrix format, it is in vector format. So we are converting the data into a matrix format. So using as dot matrix. So first we have removed the stop words from our vector. Then we converted into a corpus. Then we created the term document matrix. Now we are converting it into a actual matrix. Now call names of all TDM mat is equal to C of double quotes Facebook, comma, double quotes Google. You have to name the columns. double quotes, Microsoft. So we are naming the columns of the matrix as these three companies for which we have downloaded the data. We have downloaded the data for all these three companies, so we are naming the matrix. Okay, now we need library. We need the library called Word Cloud. After we have imported the library, we are just activating library Word Cloud. So all of you are here. Can I go forward and create a word cloud?
Yes, sir.
Well, I have to scroll the bar. That's why I'm asking, because then you can't see the content. Because the image will be a little bit longer. So just let me drag it. Okay. So comparison cloud. Comparison.cloud. It's part of your word cloud. First, we have to give all TDM match comma random order is equal to false. Random order is equal to false, comma color. We have to specify the color. So color is equal to C of, let us say, red, comma yellow, comma double quotes green. So we have specified the three colors, okay, for the comparison cloud. Come out of the first bracket, comma title dot size is equal to 1.5, comma max dot words is equal to 250. So let us run the comparison cloud.
So today we are not giving minimum frequency.
You don't need to give. Let us see. You can give minimum frequency also. Let me see the cloud first. Oh, words are less here. So we have to increase the words to 500. See, all the red words are related to Facebook. All the yellow ones are related to, yellow is not visible properly. So we will make it blue. Okay. And max words is 500. We'll make it as 500 so that we can get a complete cloud. I think we have to remove the internal names also, because anyway it is giving external names to the cloud. Let me show you the cloud actually. See here, it is giving externally. So blue words are all Google words. The red words are all Facebook words. Green words are all Microsoft words. You can see Minecraft, Font, Game, Roblox, Thailand, Google Map, Israel, this, Facebook, these words, right? So yeah, that's what. If you want to clear it out, you can increase the maximum size word size. So this comparison clouds, you can do it as very interesting. You can increase it up to max words 1000 also, and you can do comparison cloud for maximum 4 companies, so that you get a good cloud. But I have seen clouds what you call comparison clouds done for 6 companies, 8 companies also I have seen. So this is the easy way of comparing the clouds.
So can you share some research papers where all these things have been implemented and used?
Yes, yes, okay. So, Google Scholar. So, word cloud. Yes, superlative model using word cloud for short answers evaluation in e-learning. So, so in Google Scholar you will find see spoken word cloud clustering recurrent patterns in speech. So you can compare speech of Donald Trump with his competitor. So you can create a comparative cloud analysis, right? So word cloud is one of the interesting thing used in understanding speech, text, answers. So you can see a lot of papers are there. All reputed journals only you can see. See here. Sentiment analysis using latent accurate allocation, topic, polarity, word cloud visualization. IEEE thing. See? So you can see this. So if you go to Google Scholar, you can see a lot of these word clouds being used for research purposes. See, visualizing psychological networks, a tutorial in R. So you can see a lot of papers are being published in word clouds R. So you can use them as one of the parameters. You cannot use it as a sole parameter. Best would be topic modeling and word cloud. Suppose if you look at my papers, I have published in topic modeling and word cloud. So generally I use both in my papers. So you can't simply use one thing. You have to use both. So let us say text mining, topic modeling. Code McMurray, better communication. So I am interested in after communication. This is purpose for channel only. The Fort McMurray wildfire disaster in Canada. One whole town got burnt because of the wildfire. So I have used in this paper, you can see here, latent accurate allocation only. So frequency, key terms, correlation analysis, then topic model, Gibbs method, cluster dendrogram. Oh, I think I removed the word cloud, but you can use cluster dendrogram. Instead of cluster word cloud, I have used cluster dendrogram here. And then the topics. See, topic models generated by methods. So you can use this as a method. I think the Nepal earthquake paper should have it. Generally, that was one of the old things. So let us see on this paper. So in this paper, I have used word cloud also. The problem later I found with word clouds was it has to be done in color. That would be better. Now in black and white, we are forced to then word frequencies, then cluster dendrogram. This is the first paper which I published 5 years back, where I've used word cloud and cluster analysis. That time topic modeling was not that accurate. So this is a very old paper which I published Disaster Management Journal. So I think this was 2015. This was in 2015 actually. The paper was published in 2015 or 16, sometime like that. There's a paper, I think the published paper I forgot, somewhere it should be there. Yeah. So this is the Nepal earthquake which happened, right, in 2015. Very big earthquake that happened. So I did that like at the time it's text communication, how it is happening. So here in this journal, word clouds are there. And cluster dendrogram. So you can use them in marketing areas, or you can use it in text areas.
क्या नहीं है एक मिनट इधर देख. Please find it.
Sir, I'm getting an error in the word cloud.
Okay.
It says that I've typed it in the chat box. Get error in scale 1 minus scale 2.
Non-numeric argument in binary operator, two binary operator. Actually, ma'am, you might have made a spelling mistake somewhere.
Okay.
So you
Everything worked like all names, everything went properly.
okay?
Library also was, so there was no error. Everything
Okay.
went fine.
Maybe you might have made a mistake in this part only somewhere. Just I'm copying and pasting them here. Just look at in the chat window. Just look at them.
Okay, and sir, one more thing, this call names command that you have given, right? The software will be able to understand this is Facebook, this is Google, this is Microsoft. If you have 5-6 companies,
What, madam? I didn't get you.
so this command number 49,
Yeah.
like this Facebook, Google, Microsoft, we are giving them the names.
You're coming in.
We are giving them the names. So the audio problem is there somewhere, sir. Not able to, goes as an echo.
Okay.
Now it's clear. So this command number 49, can you explain that, sir?
So we are just adding the names to the column. See, what happens is once you convert it into matrix, there should be some name to the column. Now, otherwise the data cannot be distinguished. Which one is which? So we are adding the column names. Call names is a command to add the column names. So we have to give the same sequence, na? Facebook, Google, and Microsoft. So we have been continuing with the same format. So we have to give the same sequence of names also.
Okay, the same sequence. We can't change that.
The sequence of the names should be same. So from the beginning, I am using Facebook, Google, and Microsoft. So the same sequence must continue.
Okay. And the second thing is this collapse is equal to this. What does that mean?
So collapse into single column.
Okay, single column.
Generally, what happens is the text has spaces, na?
Yes,
so when you copy and paste the data in Excel or some place, the spaces will be taken as a delimiter and it will be put into different columns.
Right.
So collapse is equal to means you tell it to completely put the whole sentence into one single column.
Yeah, now I understood. Yeah, fine.
Right, that is the thing. So collapse is equal to whenever you use paste and collapse, you have to use. Sometimes you have to, suppose you are doing a test for the students, answers will be their short answers. You can you copy paste them, each word will go into one column, right? If you're putting in Excel. So if you say collapse, it will be putting everything into, it will be pasting everything into one single column.
Okay.
No matter the size of the answer. In fact, I have put the paste and collapse in resume analytics. We work on a project called resume analytics where each complete resume content was pasted into one single cell of Excel.
Okay.
You know resume, right? It goes out. So 2000 resumes, 2000 rows and 2000 cells, we have put it into that one. So this collapse and paste will put the content into one single column.
Fine, sir. Right.
Sir, the last one, comparison.cloud. Can we just explain that, sir, is equal to C in brackets?
What happens is, first we have to give the matrix. Then we are asking the random order to be true. Generally in cloud, we take random order is equal to true. But we can't take the random order here because we have 3 different components. So we are saying random order should be false. So if you say random order is equal to true, there is a probability that all of one company tweets might come into, words of one company might come in there. So you eliminate the random order and then you assign colors to each of the companies. Now if you don't, everything will come in black color.
Okay, sir.
But this is like a thing. Title size is size of the title and maximum words, how many you want in the cloud. I said 500 words. So all the things are cloud with 500 words so that you can get a good cloud.
Because we said random order is equal to false, it will now take in the same order Facebook, Google and Microsoft.
Exactly.
And then it will give red, blue and green in the same order. Okay.
Facebook, Google and Microsoft, same order.
Okay, sir. Thank you.
So
Excuse
please
me.
copy this comparison command and put it in the chat. No, sir. I'll find out later on what is the problem.
Yes, yes, yes. I'll send you the code, no problem. Or if you are using the same code, replace this whole code. Till text and clean you have, right?
Yeah, yeah, everything is right. I'm using the same code, the same
Yes,
file. That you
I'll copy it from here. You can replace your code with this and you can run it.
right, sir.
Sir, just like yesterday, you will be sending today's code also at the end of the session?
Everything is just like the video. You got the video link, right?
Yes,
So
yes, sir.
the record will be, video will be there for you in the Google Drive because it's a 400 MB video. So
Yeah.
I'll be there. I've given you the editor access to the folder. You can download anytime you want.
Yes, thank you, sir. Because this thing helps us later on. I practiced everything yesterday evening, so this helped a lot, sir.
Yes, yes. Take it, no problem. You can use it in your classroom. You can use it. I am giving everything for you. Even madam is asking for some books and references. I'll send them. Because there are a lot of books in Python. What happens is nowadays Python is most preferred in natural language processing. I have seen a couple of books. Today I'll definitely upload into the shared folder couple of books related to NLP R. So NLP Python is widely used. Speech analytics, translations, all those things, chatbots. Somebody told me that they're working on chatbot package in R. I have not seen it yet, but there is a chatbot package in Python. You can just do a chatbot in a matter of minutes.
Excuse me, sir.
Yes, sir. Yes, sir.
Sir, I'm also not getting output. I'm getting some error. I pasted it in chat box.
Okay.
With,
Just I pasted this code now. Copy and paste it from.
yeah,
this.
I've done, sir. I've done. Again, I'm getting error, but the error is different. Error in encall term matrix. I pasted it in the chat box, sir. The new error. Just a minute. Yeah, now I'm getting this error.
So sometime while pasting, there is an error of spacing. We need to make sure that there are no thing related to spaces and indentation also.
Yes, yes, you're right.
Okay.
Srikant sir, see
Sir.
48 line. What is the name you given to the matrix? See, when it says not found, it's a spelling mistake. Now for the 48 line, check in your code what you gave name to the matrix.
Okay.
See, when object not found means there is a spelling mistake.
I see. Okay, sir. I'll check it.
Just check whether your name is mistake or within the brackets matrix is mistake.
Okay.
Either
Okay.
these two will be a mistake.
Okay, sir. I'll check it. Thank you.
Or just check double M or something you must have given. So just check it there.
Okay.
And also check all TD match. Here also you have to check. The name should exactly match.
Okay. Okay.
See, all these three names should exactly match. See here, if I click on this, the three names get highlighted.
Okay, sir. I'll check it. Thank you.
Yeah.
Sir, even I'm getting error.
What are you getting? Same thing, huh?
Yeah, error. This time the error is different. I'm pasting it in the chat window. I run everything, whatever you said. This is what I'm getting now.
String with word text centricity is equal to size invalid CXC value. Why you give CEX value? What is the value I have given here?
1.5 is copied the same and pasted. Yeah.
Title dot size?
Yeah, it is 1.5.
No. Is the command correct? Title dot size.
Yeah, absolutely.
Okay. AnyDesk, ma'am, just show me your that AnyDesk can show me your content once. I'll find out the problem.
Yes,
Just
sir.
just AnyDesk. Sir, Srikant sir, you also do the AnyDesk, na? I'll just solve it up in 2 minutes. No problem.
Hello, sir. Any desk is open, sir.
Just
What
open.
is the number? 724.
1 second, sir. 1 second. Bake sir, can I put all the code in your this thing?
Sir?
I have already sent you the data, Bake sir. So you can run the code from here, comparison cloud. You just check your email ID, sir. Bake sir, you will get all the things there. Meanwhile, Bake sir can run the code. Oh, it is not breaking. Complete code, it is not breaking. I've already emailed you the data set, sir. You can copy and paste this code and run that. Okay. So let me go to AnyDesk and solve the problem. Yes, sir. Srikanth, sir. Tell me your code, sir.
724
724
926.
222, right?
Yes, sir. 222. Yeah, exactly.
I'm connecting it
Okay.
from your window. Where is the code, sir?
Sir, codes are in console, sir, below the second panel.
Okay, you're directly doing it.
Yes, sir. Yes, sir.
Oh, that's the problem. You can't connect the code in console. So you have codes related to all TDM. So here what you get is you forgot all TDM here. Sir, 61
Sir, sir.
all TDM MAT you have forgot you have this MAT here. 61
Okay.
line
Okay.
MAT. All TDM MAT. Yes, that's sir. I got it. I didn't give you that.
Mhm.
61 line add MAT. Or let me add. Then here also MAT. So first let us run the corpus. All corpus, all TDM math, all TDM math. Yeah. I'm disconnecting. Huh?
Okay, sir. Thank you. Thank you. Thank you.
Sir, I will give you my
Yeah, ma'am. Yes, your is 591
247 166.
247, right?
Yeah,
247
1 double.
166.
Uh,
Now minimize any text information. Madam, in the all,
Yes.
you have to put double quote.
Okay.
You see, text cannot be
Okay. For
Just add
each
double-
everything.
for all three.
Okay, 1 second, sir. I'll just put it and let me see.
You can select the word and put double.
So I have a request.
One single quote.
No, no. Here.
Okay, yeah.
Each word is double.
Okay. Should I run it?
Yes,
I'll do it,
please.
madam.
Two spaces. Okay. So I have to minimize the screen to select the file. Yeah, it's your Facebook.
I will get a code.
Sorry, sir?
I'm not able to identify the error.
No problem, sir. We'll look at it too after the end of the session, sir.
Ma'am, have you called the files? I guess files are not properly called.
The files have been called here. Where
Kindly check.
Yeah, we'll check it later. Okay, let's go
Ma'am,
forward.
while copying and pasting the command,
No, everything has been cross-checked. No problem anywhere. Anyway, we'll see later on. Thank you.
So this is the process of the comparison cloud, which I talked about. You can compare the words of keywords, and now you can continue the process what we have done yesterday. Now you can find the frequent terms, association, everything what we have done yesterday, and you can continue your analysis, and you can do the topic model also. Okay.
Excuse me, sir.
Yes, sir.
Sir, can you please explain the output? How to read this output?
The output is just if you look at the keyword. See, Google, AdWords, key, map, remove, Chinese, replace, Israel, death. These are the words which are coming in Google frequently.
Sir, voice is breaking, sir. Voice is not clear.
1 second. Is it clear now?
No, sir.
Okay, now it is clean.
Yeah, now it's clear.
Yeah. So, Facebook, the keywords are account, hacked, speech. These are the tweets related to Facebook. If you look at Microsoft, I think they have launched a game console recently. So all the words are related to Microsoft console. See, game. The green words are all representation of Microsoft. The blue words are all talking about Google. And the red words are the keywords related to Facebook. So if you look at Facebook keywords, it talks about account hacked and disabled, hate posts which are there. And if you look at Google, it talks about Google Maps, because Google Maps is now widely referred because of that India-China Galwan Valley. Google
Yes,
Maps
sir.
is one of the most searched thing on Google as of now, because most of them are Google Maps only, right? So country, maps, Chinese,
Okay, okay.
India. So all these relevant words are coming for Google. Similarly, Microsoft recently launched a game console, the new PSP is
Mhm.
thinking of. It talks
Okay,
about the
okay.
game. Minecraft is a very popular game on the console. Skyblock, Roblox. So these are the keywords which are there in that particular. For each of the particular set of tweets, it will identify the keyword. And
Okay,
the
okay.
more frequent the word, the larger the size of the
Size,
word.
okay. Mhm.
That is what this means. So we just see whether the words make sense or not. Now look at Google Maps, it makes sense because India and China are in a word situation and the maps are being widely used.
Yes,
Boycott
sir.
China,
Yes, sir. Mhm.
Corona, death. Israel is also now in some issue. Geo. See, you can see here Geo also.
Okay,
Because
okay.
they are tied up now. Google is tied up with Geo yesterday only.
Yes, sir.
Come to it. So
Mhm.
when you look at a word cloud, you need to see whether the words are relevant to the topic or not. Whether the words
Okay, okay.
are relevant to the topic or not. Nowadays, Twitter is very particular about it. Initially, lot of unnecessary, unrelevant words used to come in the word cloud. Then we used to say the communication is not happening as per the requirement. Now, based on this, we can say only relevant conversations are happening on that handle. If you look at Google, at the rate of Google, all these words are related to Google in some way or the other. That means the communication which is happening on Google handle are most
Okay.
relevant to Google only. So there is no term which is not relevant to Google. Similarly, all the terms related to Facebook tweets are, you can see here, some hacking problems, hate post
Yes.
issues again are coming regarding ads issues. So these words are relevant to Facebook. Similarly for Microsoft. So when you look at a word cloud, you
Okay,
make
okay.
sure the words are relevant to that communication.
Okay, okay.
Nowadays, Twitter is very perfect. Earlier days, it was a lot of unrelated words used to come. When I did my first word cloud, I had to clean a lot of things because unrelated words used to come. Nowadays, Twitter is holding.
Okay.
So those unrelevant messages on that particular handle, Twitter itself is blocking them. Now using this thing, we can see only the words relevant to that particular. We can make a conclusion that only the relevant, the communication on @Google is most relevant to the organization or the company. That is what we can conclude from the word cloud.
Okay. Okay, sir. Thank you. Thank you. Thank you.
Okay. So this is the comparison cloud. You can download tweets of different companies and then you can compare them. All right. Now, nowadays, because of the content being very, very large, there is something called text-to-vec models, which are emerging in natural language processing. We call them as text-to-vec models. So let me introduce to you a text-to-vec model. Or it's a deep learning methodology. Okay, all right. So see, Google has created this text-to-vec. They use in their things. It finds word embeddings or how do you find relevant words to a particular concept? The classic example of word embedding is autofill in your Google search. Suppose if I'm searching text-to-vec, see, it is suggesting me Python, R package, text-to-vec versus word-to-vec. See here, word-to-vec. So these auto suggestions, how these auto suggestions happen? It happens because of word embedding. So one of the most popular algorithm is word-to-vec or text-to-vec. I think word-to-vec is the Google generated algorithm. Yeah, it's a two-layer neural network. See here. I forgot, it's not text-to-vec, it is word-to-vec. This is created by Google. See here. So what happens is it assumes that words have similar context. It goes on basis that words that have similar context also have shared semantic meanings. So it predicts a word by using its neighbors, by learning dense vectors called embedding. Embedding are nothing but vectors which are created from the data of the word which you are suggesting. Using that set of embeddings, it will create the neighboring words. It will try to identify the neighboring words. So the same thing happening in the topic modeling also. The same thing is happening in topic modeling also. But what happens in topic modeling is, yesterday you understood that latent dicrete allocation, right? LDA. So what LDA will do is, it will create two matrices. One is document term matrix, and the second is term topic matrix. Which term is coming in, which topic also it will create a matrix, and it will multiply both the probabilities and it will create a final topic versus term matrix. The final topic versus term matrix will tell you where exactly the word fall under which topic. So that is latent dicrete allocation, which is a GRIP sampling method. Now what Google guys did was, they started working on this autofill and all the things. Even Google Gmail also has autofill. So they started to do work on this and they use this neural network. If you look at this neural network, the input vector, and these are the neurons, hidden neurons where the data will be processed, and the output layer. It will calculate the probability of context is equal to I. The probability of context is like, the probability of context of watching, and the probability of context of movie, and probability of context of enjoy. It will calculate different probabilities based on this one sentence called I like watching movie enjoy. this is the matrices it will create, the input vector and the output vector, right? So based on this vector, it uses a neural network which is of this nature, and then it will finally give you the suggestion or the embedded word. Now the classic example is the Google search. So the Google search uses this word to vec methodology, which is based on a neural network. So in a neural network, you have the input layer, input vector, and then the hidden layers, these will be having the functions. Now, some of you might have attended my neural network session, machine learning session. That time I talked about the neural network activation functions. The hidden layer neurons will have activation functions. So if you look at the activation function, the most popular activation functions are this. So it uses these activation functions. Let me go back. I think we'll need to get a good one. Yes. So these are the popular activation functions which are there in the neural network. So here it is using softmax. Softmax means more than 2, because you have output is more than 2, right? If the exactly output is 2, you can use the sigmoid function, which is your what you call logistic regression function, because if the output is 2, but in our case the output is more than 2, so you have to use a multi-layer, this one rectifier softmax we have to use. So these activation, these formulas are incorporated into the hidden neurons. These neurons will take the output, use that formula, calculate the value, and then send it to this. Again, there will be so there will be values here. The lines will have something called weights. Each line will have a weight. These weights are randomly assumed. The weight must be between 0 and 1. For every line, a weight is assumed. Say for this line, the weight can be 0.80, this can be 0.50, this can be 0.60. These initial weights are randomly assigned. Similarly, each of these lines will also be initially assigned a random weight. Now, once it runs this algorithm, finally it will calculate the probabilities of all the 5 options. And if the probabilities are clear, it will stop. If the probabilities are not clear, say all of them got equal probabilities, or if the algorithm is not able to make sure which one is the right output, then it will start correcting the weights. That process we call it as backward propagation. So in backward propagation, first it will reduce these weights, these all weights it will reduce, and then it will reduce all these weights and redo the calculation again. Again it will try it. It's an iterative process. So backward propagation is adjustment of weights in the connectors of the neural network. So all the output weights and all the input weights must be adjusted. That is called backward propagation. Now, how it adjusts is, it adjusts using something called gradient descent algorithm. That means the weights will be adjusted in smaller quantities or smaller proportions, typically in the multiples of 0.01 or in the multiples of 0.05. So the gradient descent algorithm says you should always start adjusting weights with smaller proportions. As you reach your goal, you can slightly increase the weight, but always the weight must be smaller. So if you look at the gradient descent algorithm, which is a very popular algorithm in neural networks. So the gradient descent algorithm says the weights must be reduced in such a way that the error or the value, the error or the cost reduces. See, it is reducing the weight in smaller proportions. Sorry guys, the power went off. Just got power went off. Everything got disconnected. Are you able to hear me now?
Yes, sir. We can hear you now, sir.
Power went off, so I got
Okay.
disconnected.
Yes, yes.
1 second. Yeah. See here, gradient descent. The initial weight is this. See, it is reducing the weight. The arrow represents the proportion of weight being reduced. See, here is also suggesting 0.01. So slowly reduce the weight. That means if you
Sir?
reduce it in larger quantities, yes, please.
Sir, can you explain, taking an example as to where do we use gradient reduction and descent, and what is that weight reduction? How can we reduce the weight?
See, 1 second. Let me show you an example. The neural network calculation example I will show you. See, initially, the data was this. Initial network is this. It's a 3-input weight network with this weight. 3 neurons are there. I'll show you the image also. Where is which one?
Hello, sir.
Yes, ma'am.
When you type something in Google and you're going to the images, అది click చేయగానే అది paper లోకి ఎలా తీసుకెళ్తుంది? How is it taking it to the paper, sir?
You have to double click on the image, ma'am.
Okay, okay, sir.
Once you double click, it will take it there.
Okay.
See, this is the network. 2 input layers. Okay, 2
Yes,
input
sir.
layers are 1 and 1. The output is 0. Output is 0. Right? And there are 3 hidden neurons in one layer. This is one hidden layer with 3 neurons. These are the neurons, which are like our human brain neurons, how we interact with how we learn and all. So these are the neurons. Okay. And this is the input 1 and 1. The output is this. This is the sample data. See, we are modeling this last observation. 1 and 1 are the input and 0 is the output. So what the algorithm neural network will do is, first it randomly assign weights to these arrows or the connectors. These 6 connectors are there, right? Each connector will be assigned a random weight. Now the random weight must be between 0 and 1. See, it assigned this. These weights, these are called weights. These numbers which you are seeing on the screen are called numbers. All of you are able to see the screen diagram, right? All of
Yes,
you are able
sir.
to
Yes, sir.
So the algorithm starts with random assignment of weights for the 6 input connectors and the 3 output connectors. These are randomly assigned. You do not have any control. These are based on random assignment of weight, right? And then what it will do is, once it has assigned the random weight, then it will start the calculation. the calculation is little bit is similar to your multiple linear regression. What I mean to say is, it will say input 1 into weight 1 plus input 2 into weight 2. That means this student neuron will have 1 into 0.8 plus 1 into 0.2. The value of the hidden layer would be 1. Similarly for this, 1 into 0.4 plus 1 into 0.9. This would be 1.3. Similarly for this, 1 into 0.3 plus 1 into 0.5 is 0.8. Now this 1.3 and 0.8 will be activated using the sigmoid function. This calculation which is there is activated by sigmoid function. See here. So the input weights are assigned, and look at the calculation here. See, 1 into 0.8 plus 1 into 0.2, then 1 into 0.4 plus 1 into 0.9, 1 into 0.3, you'll get these values. Now these values are collected into whatever converted into sigmoid activation, 1 by 1 plus e to the power of minus z. That means 1 by 1 plus e to the exponential to the power of minus 1. Now the sigmoid value is what? 0.73. Similarly, it will use the same sigmoid function, 1 by 1 plus exponential to the e minus 7. This is nothing but the logistic regression equation function. Okay, so it activated the values. Now then it multiplies this with the actual output weights. So these are random assigned weights at the beginning of the algorithm. Now the summation of all these things would be 1.23. Now again it will activate 1.23 with the activation function. It got a value of 0.77. Now you remember, if the value is greater than equal to 0.5, it will be assigned a value of 1. If the value, probability value I'm talking, is less than 0.5, it will be assigned a value of 0. This is the classification rule. This 0.5 is nothing but probability. Now based on this rule of probability, the assignment of this value would be not 1, but it would be 0, not 0, it would be 1, because this is greater than 0.5. But what is our actual output saying? Our actual output is saying it is 0. It must be 0. It cannot be 1. So what means this process has wrongly predicted the value. Now it will start the backward propagation. What is backward propagation? Correction of weights. See, it finds the weights and it calculates the weights, and see the new output weights are this. Initial was 0.3, 0.5 and 0.9. Now this has reduced the weight to 0.1, 0.32 and 0.70. Similarly, the input weights were there, 0.8, 0.2 and 0.3. They also been adjusted. Now these are the new adjusted weights which are calculated by the algorithm. So I have passed these weights, new adjusted weights, into the next iteration, and still the error is more than 0.69. So this whole process has to be removed, the weight adjustment, till you reach the target of less than 0.5. See, in my fourth iteration, I reached the value of 0.48, where the assignment of this value would be 0. Then the algorithm has corrected itself correctly. So this is a neural network. So neural networks are based on correction. They self-correct the values based on something called sigmoid prime derivatives. It uses the derivative calculations. The formula for sigmoid prime derivative is used here. So that's a derivation which you can see in Google. Sigmoid prime derivative. So where is it? Yeah, derivative of sigmoid. See here, this is the formula it uses. So sigmoid prime formula is sigmoid into 1 minus sigmoid of x is equal to 1 minus sigmoid of x. This is the whole derivation which it takes, derivative of sigmoid form. So it uses this formula, sigmoid of x into 1 minus sigmoid of x, and it starts calculating the new adjusted weight, and this is the formula it uses to correct the adjusted weights. So this process we continue till the point, it will continue till the point it reaches its goal. sometimes after the maximum iterations, it might not reach the goal. So we have to specify how many iterations we need to have. So this is the concept of what you call neural network. See here, initially 0.8, 0.4, then the formula calculations it will do, sigmoid activation it will do. You can, I'll share the link in your chat window. You can also check it. If you are interested, you can manually calculate in Excel also. Everything is there here. So it will give you the new hidden outputs. See, very detailed calculation is given here. See? Target is 0, but calculated is 0.77. Then it will start the backward propagation. First, it will adjust the 3 output weights. Okay. Then it will adjust the other 6 output weights. So a lot of formulas are there. Ignore them. You can. I'll share the sheet also. You can see the simplest form of all these formulas and it's a very complex calculation. So see the new weights 0.116, 0.32, 0.9. Still the target is 0.69. So it will do till the point the calculated goes to less than 0.5. This calculation is continued till it reaches the goal of 0.5. Then it will be classified as 0 based on the classification rule. So this is the concept of neural network, which is widely used in, these are the fundamentals of deep learning. If you are looking at deep learning, it is nothing but multi-layer neural network. It is a multi-layer neural network. Yes.
Sir, what you've shown just now, the sigmoid prime function and backward propagation and the repeated calculation till 0.5, where in management can we use this, sir?
Ma'am, nowadays what is happening is, if you want to predict stock prices,
Sir.
you might have heard about angel broking.
Yes, sir.
Angel broking has launched they have developed a neural network to predict the stock prices.
Okay.
So if you look at their flagship product, Angel Broking, I think what we call it, they have, I forgot the name. If anybody remembers, it's a very popular product based on
ARQ or something?
ARC or something, na? Yes.
ARC or something, yes, sir.
Yeah, Angel Broking has is the first company which uses neural networks. So they use this neural networks very widely in their advisories. ARC, ARC.
ARQ, I think, sir.
Yeah, so these neural networks are used in finance to predict stock prices. In consumer behavior, we use it to predict the what you call recommendations. Recommendation engine is there, right?
Yes,
If you
sir.
log into Amazon or you log into any website, you get recommendations relevant to the product.
Recommendation
That
engine, yes,
is
sir.
also based on neural networks. In the back end, neural networks will create embedding. So if you are buying a mobile phone, what all can be sold to you? A cover can be sold, screen guard, scratch guard can be sold, or you can be sold something related to SIM cards or something. So all these neural networks are everywhere now. Autonomous driving, self-driving cars are nothing but neural networks. Image processing, facial recognition, cognitive sciences. Consumer behavior is now moving to cognitive sciences and neural sciences. So what some companies are doing is they're asking their consumers come to their lab and they map the neural signals. Procter and Gamble, Unilever, they are running this cognitive neural what you call experiments in Europe and USA. So what they do is they'll request the consumers to come talk about their product, what you call popular products like Horlicks or P&G, or Unilever popular products like Surf Excel or something like that. They calculate, they get this data based on the facial expressions and all. Or they will ask them to come for a focus group discussion, and the algorithms will calculate the facial features, body languages, and then this neural networks are used. Nowadays, neural networks are everywhere, ma'am, including your traffic cameras.
Yes, sir.
Everywhere neural networks is there. Your iPhone facial recognition is a neural network. So neural networks are being widely used. So auto suggestion. In Gmail also you have auto suggestion, right? The moment
Yes,
you
sir.
type thanks, automatically end regards will come. So if you look at the auto, see I am here, if you compose any message, Google will start suggesting. So basically it will start, see, how are you doing? It is suggesting doing, see.
Yes,
This is
sir.
called embedding. This is called word embedding, which is nothing but word-to-vec algorithm working. See, you can see doing in the after the how are you I type.
Yes,
Now
sir.
it is automatically filling doing. Now you move your arrow to the end, it will automatically fill. Now if I say thanks, and it should say regards automatically. I don't know why it is saying. Sometimes it will say. So this auto filling option is nothing but used by word-to-vec model. So Google uses this word-to-vec model
Yes.
to suggest what words can be suggested to the autofill. So if you want, you can see a complex diagram also of this word-to-vec model. This is owned by Google actually. They've made it free for use for all the researchers to fine-tune the model. So they have almost 200 neurons, the probability of cathodes, all you can do lot of experiments on neural networks. But the challenge is you need to fit the exact neural network. That is the biggest challenge. So we will use this word-to-vec thing in R. They have given this word-to-vec in R also. We will use that in R, word-to-vec algorithm. So for word-to-vec, you can create a new script file. Click on new script file. Okay. Now the package name is text-to-vec. You can install the packages. Text-to-vec. Text-to-speech is also launched by Google. Speech translation. See, the word-to-vec is also there. Yeah, word-to-vec is also there. Install both the packages. Let us see what happens. And also install tidyverse. This will install all the relevant tidy packages, tidyr, see all the things it will install, tidyverse.
Sir, I request if you can import one PDF file and show how to go forward, because I'm not able to call a PDF file.
I'll do it, sir. Once we run this model, I'll do it. Okay.
Great. Thank you, sir.
Yeah. Okay. All of you have installed the packages. Now we'll activate them. Library tidyverse. Library text-to-vec. All right. Now, this comes with an inbuilt data called movie reviews. This is a very powerful movie review data frame. You can see the data related things in help actually. There is this data set, data called movie review. Okay, this is a very popular IMDb movies data set which is given by IMDb for identifying the positive and negative movies and all. 5,000 IMDb movie reviews. And it has this thing, data frame with 5,000 rows and 3 variables. ID of each review, sentiment of the review, whether it is positive or negative. 1 represents positive, 0 represents negative, and the actual review. The word actual review you can see here. So this data movie review comes with 3 inbuilt. I'm just changing the data so that you can have a flavor of this thing. So ID of each review, sentiment whether it is positive or negative, 1 being positive, 0 being negative, and then the actual text of the review. So you can access the inbuilt data set here, which is a movie review data set. IMDb is a very popular movie review in US. It's a very popular movie reviewing site. Even you also know IMDb. So if you say head movie review $review, comma 2. Let us see the first 2 movie reviews. Only the first 2, so that we can see what actually see. The first review is this. It's a very large content. See, with all this stuff going down at the moment with see, I have listened. So the review itself is very large. It's not like tweet. If you look at tweet, we maximum have how many? What is the maximum size now? Earlier it was 140. Now what is the maximum we can do in a tweet? Anybody can suggest? I forgot 250. Yeah? Now we have 250 words in a tweet. They increased. No? Earlier it was only 140 characters. Now I think it is around 250 characters. I'm not sure actually exact number, but let us check. So if you look at these reviews, some reviews will be 500 words, some reviews will be 1000 words, some reviews will be 800 words. So these are the actual reviews in an IMDb movie for 5,000 movies they have given. So so these reviews are there, and based on this whole content, they have developed an algorithm which said the whole thing is positive or negative. Positive being 1, negative being 0. So if you look at this head, movie review $sentiment, comma 2. So see, both are positive sentiments. Both are positive sentiments. See here. But if you read the whole thing, okay, the classic War of the Worlds by Timothy is an entertaining film that obviously goes to, it sounds great effort and lengths to faithfully recreate. So it looks some sort of positive only, right? So this is the real-time challenge. Amazon product reviews, that data set is also freely available. So some people write simply 1-word review, good. Some people start a lengthy complaint. So the review sizes will change. So this, when you have this sort of scenarios, the text-to-vec algorithms really work well. Okay, so let us start working on the text-to-vec. Now, prep underscore function is equal to lower. Prep underscore function is equal to lower. Then token underscore function is equal to word tokenizer. So there is a tokenizer which will split. So we have corpus. So in R we use both words. Corpus is also groups of words. Tokens are also words. So in Python we use the word token. So word tokenizer means it will split the sentences into individual words. So prep underscore function is equal to lower. Talk underscore function is equal to word tokenizer. Now we will use the model. IT underscore train is equal to I token movie review $review, comma movie review $review, comma pre-processor is equal to prep underscore function comma, tokenizer is equal to token function. See, you have two types of tokenizers. One is sentence tokenizer, the other is word tokenizer. That means you can break paragraphs into sentences using sentence tokenizer, or you can break the same paragraph into individual words by using word tokenizer. ID is equal to movie underscore review dollar ID, comma, okay, progress bar is equal to false. So we are creating word tokens. We are creating word tokens. So if you look at this thing, if we are breaking the complex review into a set of words. Okay. Now we'll create the vocabulary. Vocabulary is nothing but set of words. Vocab is equal to create underscore vocabulary IT underscore trained. So we are creating vocabulary. Vocabulary means word. Toke underscore function not found. Forgot to run tokenizer or what? I forgot. I typed them, but I didn't run them. Sorry. So we have created the vocabulary of words. This is the second way. We can break them in the corpus is also set of words. Vocabulary is also a set of words. But it depends on software. In Python, we use this command. So basically, text to work Google is developed in Python. Somebody wrote it in R, and they stick it to the what we call Python terminology. So what is this vocab? If you can type vocab, you can see the output. Basically, what it did is it breaks the words. See, term count, and doc count. So it break in this term count, and doc count, and then it assigns the probability values also. For every term, it assigns the probability values. See, 2 DF, 2 of A and B. It's till the last one. So these are the most frequent words, 2 of A and B, stop words. So we have to remove the stop words. Otherwise, see, they are repeating very, very high. So smallest to highest, it started creating the vocabulary of words. Vectorizer. Vectorizer is equal to, that means you are converting into vector. You remember vector source. Here they are calling it as vectorizer. Vocab underscore vectorizer in bracket vocab. See, slightly different terminologies. These are mostly Python terminologies. Other than that, nothing, same thing. So we have split, it's like creation of corpus. If you look at these two commands, we are basically creating a corpus which we have done earlier. Here we are just using the word vectorizer, and it created a vocabulary of words. Then DTM underscore train. DTM is nothing but document term matrix. Document term matrix. See, create underscore DTM is document term matrix. So create underscore DTM, IT underscore train, comma, vectorizer, comma, vectorizer. So basically we are converting the data into a document term matrix. Create underscore DTM is nothing but created document term matrix. So once we converted them to word, broken the paragraphs into words, then we created a vocabulary. Vocabulary is nothing but a corpus of words. Then we vectorized the corpus. Then we are now creating the document term matrix. We have created the document term matrix. Now we can use any of the package, what you call algorithms. We can predict the what is the sentiment. So what basically we are trying to do is, we already have sentiment. Now we have set of words. We'll try to run an algorithm and see how closely the algorithm is predicting to the actual sentiment. So that is what we are doing. So do we have the faculty called library GLM net? No. So install the package, install dot packages double quotes GLM net. Install the package called GLM net.
Sir, I'm sorry to interrupt.
Yes, please. Yes, ma'am.
Too fast. So I was not able to understand the output, sir. If it's possible, either at the end or whenever you want.
No. See, ma'am, nothing. See here.
From the start, sir.
No. Actually, see, this data has 3 columns. ID column, review column, and 3 columns are there. See, this movie underscore review
Yes.
has 3 columns.
Okay.
Column 1 is ID. ID means the person who has some username will be there, na? That one. 2 is the sentiment.
Right.
Column 2. That is coded as 1 or 0. 1 is positive, 0 is negative. Third, the actual review.
Okay.
In that third thing, you have the actual review, which can be 800 words to the very large review is there, right?
Okay.
That review is in text. So we were earlier dealing with 140 character tweet.
Yeah.
Now I think now it is 280 characters tweets. So we were breaking the tweet text $text. You remember? In this case, we use the word $text to select the text only of the 90 columns. See?
Yes.
We have just selected only the text, which is the actual message.
Yeah.
Here also we are doing the same thing. We are selecting the review, which is in a paragraph format or in a essay format. If you look at the reviews, some reviews in this data is 800 to 1000 words also.
Right.
Some reviews are less than 50 words also. So these are in paragraphs. Okay.
Right.
Now we are breaking those reviews into words. Like how we broke the text into corpus. Now what is corpus? Independent words, right? Each word is sentence is broken into individual words. Here we are using the word tokens. Tokens or words or corpus is all same. So once we broke these reviews into individual words, we created the vocabulary. You know the classic term in grammar. What is vocabulary? It's set of words.
Yeah.
Right? So we have created the word, which is nothing but corpus. If you are looking at what is the synonym of vocabulary, we call it as corpus, text corpus.
So what the first one was also corpus, right? That's also words, right?
See here, we have created the corpus here. See,
Huh.
before creating term document matrix, we have to create a corpus of words.
Right.
Here we are calling it as vocabulary.
But then you call token mean? Token means token is also creation of words, right?
Yes, yes, yes.
Both mean the same.
Whatever you do in text mining, you have to do it on words, not on sentences.
Okay.
You're getting it, ma'am? So, except the sentiment analysis, rest of the text mining is all based on individual words. And what this text to vec do, word to vec will do is, it will also focus on the neighbors. So, the context of the word can be taken from the neighbors also, right? You agree or not?
Yeah.
Now,
Yes.
let us say, I like movie, I do not like movie. So, the neighbors of the movie will decide whether it is a positive or a negative statement. Movie will not decide, right?
Right.
So this text to vec, what Google guys were said is, if I have 2 sentences like this, I like movie. I do not, I don't like movie. Simplest of term, right? Now, based on movie, you cannot classify whether it is a positive word or a negative word, right?
Right.
How will you do classification whether it is a positive or negative? Based on the neighbors. You have to look at the neighboring words. We call them as neighbors in text mining.
Right.
Neighbors on both the sides. Sometimes you have to, the word might be in the middle of the sentence. You have to look at the both of the neighbors.
Right.
Then only you can understand the context. Now,
Right.
I like movie is positive.
Right.
I do not like movie is negative. Based on not movie or like. Based on the keyword called don't like.
Right.
That is the logic Google guys have used. So we cannot, based on a single word, we can't decide the context. And then when we can't decide a context, we cannot give them a suggestion.
Okay.
So when you look at Google search, your search pattern will autofill, right? If you are searching for something on a Google search bar, the autofills differ based on the previous searches you have.
Okay.
They're not standard, right? If you have observed closely in Google search, you type any first two words, the third words will be started being, you get a list of all suggestions.
Right. Sir.
Now, these list of suggestions are not same. They are unique from user to user.
Right. Sir.
So how that user to user distinction can be made is using this word to vec algorithm. That is where Google guys have decided to build their own algorithm called vectorizer, where the neighbors are also taken into consideration to decide the context of a word, and then embedding. Embedding means what can be suggested or what can be embedded along with that particular word.
Right.
That
Sir.
suggestion is decided. So one of the algorithm is they have developed this word to vec.
Right.
Yes, ma'am. Any other doubt?
Yeah, I have two queries, sir. First, just before the vocab, can we see that bag of words? Can I type head and look into those bag of words?
You can see word
The
to vec
token
also
one.
uses. I was about to talk to you. There are two strategies word to vec uses. Word to vec uses two strategies. One is the bag of words. Bag of words means it will break them into words and taking the context. And the second methodology it uses is skip n-grams. The second methodology it uses is, I think, skip n-grams.
Okay.
That means n-grams are nothing but, suppose sometimes you have to take two words, na? Bigrams, digrams, or unigram. Unigram means single word.
Yeah.
So you can run this word to vec as a bag of words, or you can run it as a n-gram also. N-grams means unigram means single word, bigrams means two words, trigram three words. Then you have a quadgram, so you can have a set of words, and then you can also use them as a instead of take bag of words, takes individual words. Skipgrams will take the number of words you give. N-grams 8 means it will take 8 words as one single unit, and then it will try to find the context. Sometimes we type sentences in Google search also, right?
Right. Sir.
That's where n-grams will come into picture.
Okay. So then for token, can I see that output of token? Because output of vocab is easily seen because we are going to use it. But
Yes,
the
you can
output
see
of
vocab output is giving now. You can check.
the vocab we can see, but that token wala output also can be seen.
We can see. Yeah.
We just typed I_token and we can see the output also.
I trained.
Okay.
We have used the word I train, right?
Yeah, no, yeah, IT_train. Yeah, yeah.
So token you cannot see. You can see only vocab.
Vocab
So
can be
what
seen.
happens is token is a function. It's a callback function for this thing. You can see the output of vocab. You cannot see the vocab output of I train.
Okay.
So the final output is this. You can see the output of DTM train. Document term matrix is there, which you have created. That you can see. This is the document term matrix which I have created, which is a very large matrix. See, 5000 into 42,652 sparse matrix of DGC matrix.
Right.
It's a very large matrix. Or we can say, let us say, inspect will work. Inspect square bracket DTM train, comma 200 colon 250, comma 1 colon 30. Oh, object of closure is not susceptible.
Okay.
No. So we can't see the DTM train output also. Inspect is not working. I have to search for the exact command which is used here.
Okay.
So I'll get back to you later for that part. Let us build the model. All of you import this package called GLMnet.
And this model is review, right?
Pardon, ma'am?
We are doing this in the review. We are not using the sentiment, the third column. We're just doing the review one because
We are doing it on the reviews only.
reviews. Okay, sir.
There is a larger text. You can do it on our tweet data also. Same thing.
Okay. Okay.
You can also do it on our same thing. See here. Here, if you want to do it, just replace this with
Sentiment.
right? Dollar text. And then you see the IDs of the users. Now you have an ID column in tweet also.
Right. Right.
Replace it with the ID column of the tweet.
Okay.
Right. And then you can do it exactly what we are doing on our tweet data also. That you can do it as an exercise for your convenience at later stage. Okay.
Okay. Okay, sir. Yeah.
Library GLMnet. So GLMnet classifier is equal to cv.glmnet x is equal to DTM underscore train, comma y is equal to movie review dollar sentiment. Your dependent variable is sentiment, 0 or 1. It's a binary classifier, which I am building here is binary classifier because sentiment is coded as 1 or 0. So we are just building a logistic regression type classifier. GLMnet is nothing but a large scale logistic regression based classifier. Family is equal to binomial. Family is equal to binomial. Binomial means our dependent variable is in binary format. That's the other name of binary distribution is Bernoulli's binomial distribution because our y is in 1 and 0. Alpha is equal to 1, comma type dot measure is equal to AUC, area under the curve, unfolds because we are giving CV cross validation. So I am asking it to do 4 times cross validation. Threshold is equal to 1 E minus 3. 1 E minus 3 means what? 0.001, or let me give it as threshold is equal to 0.001, comma. Then maximum iteration, max it. Maximum iterations is equal to 100. You have to specify the iterations also. Otherwise, you will not be able to find the algorithm will not converge and it will create problems. So this is the thing I am running. It ran. So we can directly plot the GLMnet classifier. So it will give you the area under the curve. See, along with the confusion matrix, we also use this something called area under the curve. This also has to be closer to 1. AUC also has to be closer to 1. AUC is calculated based on the confusion matrix only. So we will get the area under the curve, which is widely used for deep learning as a robust mechanism. Otherwise, you can also use accuracy. We can see the type dot measure, where the type dot measure can also be accuracy. CV dot GLMnet. So type dot measure is equal to default. What is saying is deviance class ROC, MSC, misclassification rate, all are there. Okay. Got it? All of you got the output? You want the code to be pasted? Okay. All right. Here. I've pasted the code.
Sir, can you please paste the above two quotes?
Above also, 1 second. The above quotes are right from here. I'll paste. That's fun. Okay.
Okay.
Okay. So AUC uses true positive rate and false positive rate. You remember the TP and FP in confusion matrix. It uses the true positive rate and false positive rate in confusion matrix for calculating AUC. So AUC is also calculated from confusion matrix, which is the matrix of the predicted values and the actual values. You can see here confusion matrix. So based on this confusion matrix only, AUC is also calculated. So this is the confusion matrix which we have earlier discussed. True positive, actually positive, predicted positive. So two positive and false positives are part of AUC calculation. So backend it will do a confusion matrix, and using this confusion matrix it will calculate the AUC curve. So let me see if I can get the AUC formula directly from this article. Control F. The area under the curve is not here. Sensitivity, specificity, precision, accuracy, F1 score. Okay. AUC is a very old measure, but still we are following the AUC only. So let us see with the AUC. Where we get the actual formula is the good one. See, TPR and FPR used in ROC curve. Okay, this is the formula which are used in the assessing the ROC curve. So this must be closer to 1. Above 0.5 is best model. So this is based on the same confusion matrix, true positive rate and false positive rate. And based on these two parameters, it will calculate the area under the curve. So area under the curve will be used for checking the robustness of our model along with accuracy. Accuracy is another measure we generally use, but here we are using what we call, because it's a multinomial problem, we are using the area under the curve. So I'm sending the link of the article in chat, you can look at it. So you are getting the AUC curve, area under the curve, and you can also, actual value also you can find out. You can find the actual value. The actual value is GLM net classifier dollar CVM. Oh, we got all of them. Okay. So we have to reduce the thing. So what we have to do is max. So the actual value of area under the curve is 0.9214. Area under curve is equal to 92.14%. That is what the graph is also showing. See, it is taking a bend at 92%, right? You can see the line where it is becoming flatter. The line is becoming flatter at 92%. Somewhere around 92%, it is becoming flatter. So the area under the curve is 92%. So this is how we calculate the AUC based on the true positive rate and false positive rate. Okay, all of you got the, basically this is the bag of words model. So this is based on bag of words. So this is based on bag of words. Now if you want to use the skipgram,
So what does this graph basically signifies?
see the area, see at the 92%, the curve is becoming flatter. That means
That
at the accuracy of the model is 92% with 8% error rate. That means 92% of the predictions it is doing correctly. 8% of the observations are wrongly predicted. See, 1 second. I'll show you 1 second. The accuracy also can be calculated. So, DLM net classifier dollar number million, then you have to change it to class. Okay. Now, qualifier million, and to the solve here. We are getting to take it as class.
So this means the data which was given under the movie data set.
See, actually, the sentiment is actual sentiment. Okay, the actual sentiment is there. 1 second. Let me just give you the confusion matrix. Then all the problems will be solved. Predict is equal to predict DLM net classifier. What was the thing we gave? Vocab, right? X is equal to vocab. Huh? DTM underscore train. Okay. Table movie review dollar sentiment comma DLM net predict. You got the confusion matrix here. See, this false true means this is positive, this is negative. Sorry, negative and positive. False is negative, true is positive. So if you look at the accuracy, 2378 plus 1909 divided by 2378 plus 105 plus 608 plus 1909. 85.74 accuracy. So the model is predicting with an accuracy of 85.74. That means it has an error rate of 15%. 85% or 86%, it is correctly predicting. Wrong predictions are 14%. So you can see these two are wrong predictions. 105 is a wrong prediction. 608 is a wrong prediction. These two are right predictions. This we call it as true negative. This we call it as true positive. This is false negative, false positive. This is false negative. So using this confusion matrix, it calculates the sensitivity, specificity, TPR, all the formulas are here in the diagram which I have shown you. And you can calculate the accuracy levels and also the area under the curve level.
Exactly, sir. But I'm not able to understand where this 85% is the percentage out of this movie data set or what?
See, the actual reviews are this.
Like in out of 185 reviews are as per their sentiments.
No, that is not the thing. Movie review dollar sentiment. Okay. So there are 2,483 positive sentiments, 2,517, 2,483 negative sentiments, 2,517 are positive sentiments. This is the actual
Okay.
data. Okay.
Right.
So the actual sentiments are this. Now, if you look at the actual sentiments are this, the predicted sentiments are something different. So let us say, I am say class predict is equal to if else open bracket GLM net predict GLM net predict greater than equal to 0.5 is equal to 1 comma 0 double equal to. Unexpected double equal to. If else is double equal to 1, right? If GLM not great predict is greater than equal to 0.5, sorry, comma. Okay, see here. Now, here, what you call spread df is equal to data dot frame of, let us say, movie review dollar sentiment, comma, class predict. Okay. Now, look at this spread df. I have created a data frame called spread df. See here, movie review, the actual sentiment was 1, our algorithm predicted it as 0. The actual review was 1, our algorithm also predicted it as 1. Actual actual sentiment was 0, our algorithm predicted it 0 also. So see here, look at this. Actually the sentiment is 1, which is positive, but our algorithm predicted it as 0. So these we call them as misclassifications. These are called
So we are verifying the sentiments.
we are verifying the not the sentiment, accuracy, the predictive accuracy of our model. We are verifying how accurately this model is predicting the sentiment. So to this sentiment, to this model, if I give any other sentiment, it should tell me whether it is positive or negative. Now it is predicting 85% correctly, 15% it is predicting wrong. Based on this, this is the actual sentiment. This X1 is the predicted sentiment based on our model calculation. Okay, so this is what accuracy. So only 85% are accurately corrected. So this is a wrong classification. See, first one is wrong classification. So second one is wrong classification. So some of them, some positives are negatively predicted, some negatives are positively predicted. Right. So that is what you can see in confusion matrix. The confusion matrix will give you which one is correctly predicted and how many are correctly predicted, how many are wrongly predicted. So that is the thing you can do using this confusion matrix. Actually, you didn't understand, but for all classification models, the primary diagnostic is confusion matrix. From confusion matrix, this area under the curve is coming up. So misclassification rate is also very, very high. Okay. Next time when I do a machine learning algorithm workshop you just attend, that time we will discuss in detail the confusion matrix, what are all metrics we can do there and all. Okay. So there are two things. One is the bag of words model. The other is the skipgram model. I will just run the skipgram model. It just takes 2 seconds to run, not much of a time. So skipgram model. So in the skipgram model, the change happens from vocabulary. So we have this vocab now. So what we have to do is vocabgram is equal to create underscore vocabulary. So create underscore vocabulary. What we gave here on top, we have given it as IT underscore train. IT underscore train, comma, ngram. Ngram is equal to C of 1L, comma 2L. So what I am saying is I am asking it to make two. This is a bigram. This is a bigram method. So instead of taking single words, we are creating a bigram model. This is a bigram. That means combination of 2 words. This is a bigram model. So instead of 1 word, it will take bigram, 2 grams, 2 models. So once we have done, then the same other process. So you can copy the comments from top. So vectorizer gram is equal to vocab gram. Then DTM train gram is equal to IT term vectorizer gram. So this is a document term matrix of 2 words. Earlier it was only 1 word. Now we are getting 2 words. So you can see here, vocab gram will give you 2 words. So vocab gram we are giving 2 words, bigram thing. Or let us say 2L and 2L. Here you can see the 2 words and this movie in the of the BR underscore BR. So this is called bigram. 2L and 2L, we get the bigrams, 2 words. Earlier it was only one word. Now we are getting 2 words as the combination, vocab gram. So we have done the DTM gram. Now we have to run the same classifier. We will run the same classifier. Control C. DTM train gram. Right, that's the only thing we have. Rest of all are same. Just run the code. It's still running because it's a bigram, so it will just take some time to run. So skipgram model is the other model which we use in word-to-vec models. So bigram model. So it ran. So I have used the same name, so I should have changed it. So GLM net classifier. Max GLM net classifier $EDN. The accuracy has reduced. The area under the curve came down to 89.24. So bigram model is not the perfect model. Unigram model is the better model. So this is how we can find. So now it says unigram model is better model because this model has given us lower AUC. The AUC always must be higher, closer to 1. This has given us the lesser AOC. You can look at the code once. So this is the bigram model. It says based on the RUC, unigram model is better than the bigram model. So we'll stick to the unigram model. So this is the, when you do with large scale data, this is best option rather than the corpus option and all. This is the best option when you're dealing with large scale data. So this is the best modeling. This is based on word-to-word model developed by Google guys, which is based on the neural network. Okay. So now you can ask me any doubts you have. We'll go on.
Sir, excuse me, sir.
Yes, please.
Sir, can you please show how to use PDF file?
How to?
PDF file, sir.
PDF file. Okay.
Yes, sir.
Yes.
Now with this
I
model,
think Sahil also has the same thing, right? Sahil, you also want the PDF file download?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
1 second. Yeah. Yes, ma'am. Kavita, ma'am.
sir, now this model is ready, given 95% accuracy, or it's good. So now if I want to get another data and test it with this, so can I?
You can do it. You can do it.
What
So,
would be the
what we can do is, we have to take a set of sentiments, convert them into document term matrix, and give it as test data.
Okay.
And you can split it here only. Train and test, you can split 80 to 20% and do it like that.
Okay.
So I'm training the full model and I'm also testing the full model.
Okay. Perfect, sir. Yeah.
Got it right. Otherwise, you can split it 80-20. Again, on 20%, you have to run the DTM again and do it again. So it's better to use train and test on same data.
Same data.
So
Okay.
I am building the model on complete 100% of data, and I'm asking you to take the 100% of data as test data,
Right. Right.
and then get it. So that is that way. Otherwise, what happens is you have to repetitively do test cleaning up also, right? You have to have the test data also converted into document term matrix with the vectorizer and the thing. That's a duplicative process. So
Right.
that also we can take. Otherwise, we can, in this case, I am taking 100% as train data and also 100% as test data.
Okay. And sir, in SAS, when I was using, there were 3 concepts like entropy and mutual information. All that is not required here currently with this NLP, whatever we have learned in 2 days, right?
What, madam? I didn't understand, please.
So there were certain kind of measures. I'm not able to recollect, like entropy was there. Then there was mutual information, the sharing which happens. So all that thing is not required
That
here.
is, no, that is not required here, madam.
Okay.
So what happens is entropy and all are in decision trees.
Yeah, decision tree. Okay.
That is different. So natural language processing itself is completely different compared to your classification and regression technique. We may use the same logistic regression here, but the analysis and interpretation differs from numerical data to text data. Here we are dealing with text data, right? There we will be dealing with numerical data. So when it comes to decision tree for a natural language processing model, it's a different set of things. So generally it won't build it properly. Tree-based models are best for numbers, not for text data. So
Right.
text data is completely different. We have to treat it as a different. That's why we call it as a natural language processing. We can use some of the algorithms, like we can use decision tree also to run on it. Okay, we can do random forest on this data. We can do all those things, but the accuracy levels will not be good.
Okay.
So there are certain specific algorithms which are meant for text mining.
Okay, sir.
Those algorithms have to be used because numerical algorithms will not have good effect on text-based data.
Right, sir. And so the last thing is you were saying something that you will show us something related to image. So
Image processing, that's a completely different from natural language processing. So image processing, couple of our participants are also asking. I'll send you the invite because it comes under deep learning. And I think we have to use the Google Collaboratory because I think most of the laptops have 4 GB RAM or 6 GB RAM.
right,
For
right.
image processing, we must have minimum of 12 GB RAM
Okay,
because
sir.
images come in large scale sizes, right? 5 GB, the data size will be in GBs,
Right, sir.
the medical scans and all. And when I do a deep learning model or an image processing module, then we can discuss about that because that is a completely different field.
Okay,
And
okay.
for that image processing and this thing, we don't prefer R at all. It has to be done in Python only.
Python only. Okay, sir.
R has a problem with image processing. It does not work well with the images. It works, but compared to Python, it is a weaker thing. It takes time to converge and all those things. So Python is the best suited for image processing. There's a package called PyTorch. That is the best one for image processing. All your medical scans, satellite imagery, everything can be processed using PyTorch.
Okay, sir. Okay.
Okay. That time we'll discuss that.
Right.
I'll just show you how to import the PDF file. Okay.
Right.
So the package is PDF tools. Install this package. PDF tools. So I think I don't also have installed packages. PDF. Okay, so library PDF tools. Okay. Files is equal to list.files open bracket pattern is equal to PDF dollar files 0. Okay. So, okay, my working directory does not have a PDF file. So, I have to just copy and one PDF file from data to that place. So where do I have PDFs? One second. We need a PDF file. So file, save as, my computer, choose a different folder. Desktop. Within
So
desktop.
that means for working with Word file or a text file, we need to get some more packages installed.
One second. See, for PDF file, because my working directory doesn't have any tool, so I just saved a PDF file. Now it should read the PDF file automatically. 1 second. So list file is this. See, now it's identified the Python cheat sheet. See, my working directory. See, if you want to know where is your working directory, get WD. So, see, my working directory is desktop data text mining NLP folder. So, just keep some PDF files, or you can give this working directory to any PDF folder. So, you have this option, na? Session, set working directory. Choose
So
directory.
just like yesterday we feeded that CSV file, that Twitter file. Can't we feed here a PDF file while opening a dialog box?
No, you can't.
Okay. And to
So,
work with doc file and text file,
for text file, I think pattern is equal to list.files is there, na? Go to help. You can use this list.files command. So list.files. So pattern is equal to, I think you can give text. Pattern is equal to regular expression. So you can give it as PDF dollar, or I think you can give text or TXT. Okay. So you can give any of those regular expressions related to files thing, no? That can be given here. Now, once you have this file read, the PDF file reading means this is the only option you have. PDF file reading means this is the only option you have. There is no other option for PDF filing in R. So once you have this, let us say text is equal to, text1 is equal to, L apply, file, comma, PDF underscore text. Okay. Now you can see here, text1 is the content. What is there in the PDF file, you can see it as content here. So
but I have to do analysis for this PDF. So I have to clean the things with the same commands.
You have to clean up the PDF file, and then you have, because this, what happens is this PDF file has lot of what you call brackets and all, no? This has more of image sort of a thing.
Yes, sir.
So that is why it's not taking. But if you take an annual report or any text-based thing, you can do it easily. So you can.
So I can call that function here text clean function.
Text clean. So let us say corpus. 1 second. Corpus URI source file, comma, reader control is equal to list reader is equal to read TDF. So we have created the corpus. Now you can do, once you create the corpus, now you can do the cleaning here also. So corp TDM is equal to term document matrix corp, comma, control is equal to list, open bracket, remove punctuation, remove punctuation is equal to true, comma, stop words is equal to true, comma, to lower is equal to true, comma, same thing. What we have done, remove numbers, all those things you can do here also. This is one advantage in PDF tools. This comes under PDF tools package where you are down bounds is equal to list, open bracket, global is equal to T of 3 comma infinity. Okay. So we can create a term document matrix and also we can simultaneously clean it. Okay. So that is the advantage of this code, which I've done, which I've used now. You can automatically create a term document matrix and also clean the content and code also. Bounds is equal to list of global C is equal to C of 3 comma int. Okay, we'll remove the bounds. So we have done the corp term document matrix, right? So we can do a word cloud. Oh, word cloud didn't come. Why it didn't come? Or let us say find frequent terms. So corp TDM comma low thread is equal to 10. So these are the words that are coming frequently, minimum of 10 times. So low thread 5. Minimum of 5 times, these are the words coming. So I think corp. For word cloud, we are giving only corpus, right? Or what we gave for word cloud? For word cloud, corp. Yeah, word cloud is based on corp. So word cloud in corp. See, this is the word cloud. Plot, season, 7. So in PDF tools, if you want, because most of the time the documents are in PDF format, right? So this is the whole code of PDF where you can import the files and clean them, create a term document matrix, all the things, or document term matrix, everything can be done in one go in PDF tools. So that is the advantage of this PDF tools. So PDF tools is an exclusive package which is meant for dealing with PDF files. If you have hundreds of files, it will take hundreds of files. So here it identified only one file, right? If you suppose I put 10 PDF files there, it will take all the 10 PDF files, read the text, convert it into corpus, and you can do a term document matrix. I did it with 100 or almost 80 annual reports. 80 annual reports means close to 24,000 or 25,000 pages. But you have to have at least 12 GB RAM for doing it on a small.
So how to enter multiple PDF? This is one PDF, right?
thing. You put multiple files in the same working directory.
Okay, then it will read all the files.
It will show you all the files. Whatever file PDF sign is there, it will automatically read all the PDF files. If the folder has 20 files, it will read all the 20 files.
Okay, in text one level, it will collaborate all the 20 files.
Yes, it will read complete 20 files, and then it will convert them into all the corpus which it creates will be having the content of all the 20 files.
Right, sir. Right, sir.
So this is the easiest way of doing the PDF files. Only thing is you put all the files of PDF files in a folder, go to session, click on session, set it as working directory. Okay, choose directory. I think I should have corporate governance reports somewhere. CG reports is here. Somewhere I need to, I think I have one large data set of PDF files. CG reports, no. Data, yeah, CG analytics. So CG analytics, there are a lot of PDF files. What is this CG folder? Actually, I did it for corporate governance reports, but the model did not convert, so I have to stop it. Somewhere I stored the CG files. Let me search actually. CG reports. See, this is the CG reports folder. So I have this many files. Okay. So let me look at the path actually where this is, where this file located. Get info. So it is located in desktop blog article CG reports. Okay. So let me come back. Desktop. Hey, I forgot what folder. Blog articles, CG reports. Open. Now I have set my working directory as CG reports. Right. Now I will run the files code and click on the file. See, all 48 PDF files it is reading. See, it is reading all the PDF files. These are corporate governance reports of 48 companies in India. Okay. Now run the text. Text one, invalid font, something will come, PDF error. So it is now reading all the content of 48 files. So you can go, I think only thing is you create a folder of all the PDF files in one place and make it your working directory using the session and then run this command. It will automatically read the PDF files, the content, everything will be read and you can clean it, everything in one go. The PDF tools is a very highly used package. In text mining, when you're dealing with forensic accounting and all those things, we use this.
So please run for word cloud for this last statement.
Yeah, I'll do it. It is reading the file, no? 48 files, no? So just it will take time. This invalid font weight comes as an error when it reads some fonts are not recognized by PDF, right? So that is what, so you can forget about that invalid font thing. I think it's still reading, huh? Yeah, text one it's still reading. This is a very powerful R in terms of text mining. For some purposes, it's very easy. Python also. Okay, it ran the text. Now I'm converting. No, oh shit! It is running the text one command also. I should not stop it. So it is running the text one command again. So yeah. You can't even stop it. It's not in the stop also. You have to just wait. We'll get a word cloud easily. Yeah, I'll just require time because it's a very large container. Some PDFs have 30, 40 pages also. So just got stuck somewhere. So let us see how it should move on. I got an output actually on this.
And sir, how do you get the matter from the website?
Which one, ma'am?
Website.
What, ma'am?
If I want to get a matter from the website,
There also we have a HTML web scraper.
okay, HTML web.
There's a package called HTML and there is a package called HTML that you can scrape websites using that HTML web scraper. You can easily find the code in our website, our pubs or our Stack Overflow. You'll find the code. So what happens is it will scrape the website completely based on the access levels. If the publicly available content, you can scrape the web there. You can also read the data tables from web. So there are a lot of functionalities which are there. I think it got stuck here. It is not moving. I'm not able to stop. So web scraping is also easily done in R. There's a package for that, exclusive package like this PDF tools package is there. So you have an exclusive package there. Okay, it got stuck. It will take time. So I'll send you let us see if you have anybody who wants to leave, can leave. Or you have any doubts, you can ask me now while it is running.
Thank you, sir.
Okay. So to some extent, we will also do NLP in Python also. There we can explore with some other content. It has run. Okay. Now let us create the corpus. So it is now running the corpus. Why is it stuck here? Why is it? So basically, it's all about. Oh, what happened? So once you have the corpus, you can build the word cloud. So let me build the word cloud. See. The system has slowed down drastically. Because we are running a lot of things now. So power is there. Okay. So how many are you familiar with what you call Python? I think Begs or Srikanth is familiar. Sahil, you are familiar with Python? Preeti ma'am, you are familiar with Python? So Python is very good in terms of running this natural language processing and image processing related tools. So what I'm planning is I will do a deep learning workshop with 1 day on text and 1 day on images. That's what I was planning to do. Let me see how many interested participants will be there based on that. And one more thing, I am repeating this workshop same on this Saturday and Sunday because some of them could not attend because of their workloads and all. So if you are interested, you can join free of cost on Saturday and Sunday, no problem. So I am doing the same NLP-R workshop on Saturday and Sunday. Because some of the participants could not join because of the work commitments. They asked it for Saturday and Sunday. So I'm doing this Sunday. If you want, you can join free of cost, no issues at all. Okay, now word. happens? See, this is the problem with large scale data. It gets hanged up. Okay. Now it is activated. So let us do the word cloud. This is the problem with R. In Python, you will not get this much of problem because the word clouds and all will work properly. Here it will create a little bit slowdown of the system. It's an 8 GB RAM, but still it is struggling to create, struggling to work with the code. So I think it is creating the plot. Okay. Word cloud. Actually, I got an idea of text mining corporate governance reports, which but somehow the model did not fit. Topic modeling didn't work properly, so I have to drop the idea. Then I got another idea of reducing from 50 companies to top 10 companies. That way we might get some robust understanding of the data. But you can try annual reports, you can try with any PDF document, content, you can try with, create this sentiment. So, it's creating a word cloud. See, it's not cleaned properly. That is one thing I found difficult here. You can see numbers, strengthen, green, ongoing. It's also not able to create a power. See, the word cloud is created here. Style, sir, you can see now. But
Yes,
see,
sir.
this
Yes.
unnecessary things are there. This see numbers, I told remove numbers didn't work. So I think it's
Yes, sir.
better to use the dsub commands to clean this content.
Right, sir.
That would be the better option. You have cleaned this
Right.
command, no? We can clean the thing there. But in Corpus C 3039, G420, commissioning, portable. So all these things are coming, but they are not actually coming properly. See?
Right, sir.
Pipeline, essentially climate friendly. These are corporate governance reports, mostly related to climate and all those things. So you can try to see it here. You can create all those required things easily here. The only thing is your system should be at least 8 GB RAM. Otherwise it will hang. See, my system only 8 GB RAM, it is hanging. See, it is still struggling to cop up with this. So I would suggest if you want to do something of a higher end, go to Google Colaboratory. It's an online-based environment which is provided by Google, but it's a Python environment where you can run all these things. So because that comes with 13 GB RAM. So that is the advantage of Google Colaboratory. It's an online Python edition. So that we can use online versions, Google Colaboratory. Or you can go to Kaggle. Kaggle also have kernels with higher GPUs and CPUs. There also you'll get a lot of power. So whenever you're doing high level or high end things, better to go to either Kaggle kernels or go to Google Colaboratory. That is the biggest option. Only option we have for running this. Otherwise it will get stuck like this. All right? Any
Right,
other
sir.
doubt?
Right, sir. Right, sir.
So I'll send all the codes and the video as soon as it's done. Any other
Right,
doubt?
sir.
You can always-
No, sir. So we have to practice first, then to ask for doubts, sir.
So I would suggest you are from which background?
So I'm from basically from management only, but I've done BTech, so I'm good with coding and things.
No,
Marketing,
management.
marketing.
So what you can do is you can download these product reviews or something from some site, and you can
Yes,
work
sir.
on it. And you can publish a paper also.
Yes, sir. I am working on Python. I'm working on Python from last good time. So I'm new to this R thing.
Ah. So
I
Python
have pa-
it's butter.
I have papers with Python on Word Cloud. I have papers on NVivo with NVivo.
NVivo, yeah.
And yeah, I'm pretty much familiar with Python and Vue, both the things, but I'm not aware of the R thing. So R was quite new to me. So I had yesterday evening I spent good time on this learning the concepts you shared, uh, and today yes I have to give good time for this latest thing you
Yes,
shared with us at.
R is very easy. So when we teach students, first we teach them R, then we take them into Python.
Good sir.
But Python
Right.
is less syntax oriented, right? That
Yeah.
is what. So thank you all for attending. I'll send all the codes and the video as soon as it's done. Okay.
Thank you so much, sir. Thank you for
Okay,
all
sir.
the
Thank you,
wonderful
sir.
lectures. Thank you.